Welcome to the session on HCF and LCM. In this session, we will be discussing the HCF, the highest common factor. The objectives for this session are learning how to define and find the highest common factor using the Prime Factorization Method and division method, and learning how to solve real-life problems involving HCF. The acronym for the highest common factor is HCF. The HCF of two or more numbers is the greatest number that divides the given number exactly. Let's look at an example first. Try finding the HCF of two numbers by using the factorization method. We're going to find the HCF of 16 and 36 using this method. The prime factors of 16 are 2, 2, 2 and 2. Since 16 equals 2 times 2 times 2 times 2. The prime factors of 36 are 2, 2, 3 and 3. Since 36 equals 2 times 2 times 3 times 3. The common factors of 16 and 36 are 2 and 2. Therefore, the product of the common factors is 2 times 2, which is 4. Therefore, the highest common factor of 16 and 36 is 4. Let's look at another example. Find the HCF of 18 and 30 using the prime factorization method. The prime factors of 18 are 2, 3 and 3. Since 18 equals 2 times 3 times 3. The prime factors of 30 are 2, 3 and 5. Since 30 equals 2 times 3 times 5. The common factors of 18 and 30 are 2 and 3. Therefore, the product of the common factors is 2 times 3, which is 6. And therefore, the highest common factor of 18 and 30 is 6. We will now try to find the HCF of 18, 27 and 54 by the prime factorization method. The prime factors of 18 are 2, 3 and 3. Since 18 equals 2 times 3 times 3. The prime factors of 27 are 3, 3 and 3. Since 27 equals 3 times 3 times 3. The prime factors of 54 are 2, 3, 3 and 3. Since 54 equals 2 times 3 times 3 times 3. The common factors of 18, 27 and 54 are 3 and 3. Therefore, the product of the common factors is 3 times 3, which is 9. And this is the highest common factor of 18, 27 and 54. Let's try finding the HCF by using the division method. We will illustrate this method with the help of an example. Find the HCF of 24 and 40 by the division method. So let's begin. Divide the larger number 40 by the smaller number 24. This gives 40 divided by 24 equals 1, remainder 16. So 16 is the remainder. Divide 24 by the first remainder 16. This gives 24 divided by 16 equals 1, remainder 8. so 8 is the remainder. Divide 16 by the second remainder, 8. This gives 16 divided by 8 equals 2, remainder 0. So 0 is the remainder. The last divisor, 8, is the highest common factor of 40 and 24. Let's try finding the HCF of 3 numbers this time by again using the division method. We will illustrate this method with the help of an example. We're going to find the HCF of 16, 24 and 48 by using the division method. First, find the HCF of any 2 of the 3 numbers using the previous method. So divide 24 by the smallest number, 16. This gives 24 divided by 16 equals 1, remainder 8. So 8 is the remainder. Divide 16 by the first remainder, 8. This gives 2, remainder 0. So 0 is the remainder. The last divisor, 8, is the HCF of 24 and 16. So HCF of 24 and 16 is 8. Now find the HCF of 48 and 8 using the previous method. So divide 48 by the smaller number, 8. This gives 6, remainder 0. So 0 is the remainder. The last divisor, 8, is the HCF of 48 and 8. So HCF of 16, 24 and 48 is 8. We will now try to solve a real-life problem involving HCF. Find the maximum length of a measuring tape that can exactly measure 21, 28 and 35. So let's take a look at this. The prime factors of 21 are 3 and 7, since 21 equals 3 times 7. Similarly, the prime factors of 28 are 2, 7, 2, since 28 equals 2 times 2 times 7. And the prime factors of 35 are 5 and 7, since 35 equals 5 times 7. Therefore, the common factors of 21, 28 and 35 is 7. The product, of course, of the common factors is simply 7. And therefore, this is the highest common factor of 21, 28 and 35. This brings us to the end of this session. If you have understood the contents of this session, you should be able to define and find the highest common factor using the Prime Factorization Method and Division Method, and solve real-life problems involving HCF. Thank you very much for listening. Now pause the slideshow and have a go at these exercises. The solutions will be released one at a time so you can check your answers as you go along. Pause the slideshow whenever you need to.